And it looks like we are 12% of the way through 4th grade. So I figure with unit tests and the course challenge, it's probably going to take me a total of 10 or 11 streams to get this done, but we'll see. For now, we are 12% of the way through 4th grade, and we begin with another unit of addition, subtraction, and estimation. Now, you may remember that last year, quote unquote, in the 3rd grade curriculum, there was another unit called addition, subtraction, and estimation. That's on purpose. We are taking the same ideas that we used last year, quote unquote, and we are just adapting them a little bit and making them a little bit more complex. Now, this was an area that I actually struggled with in our 3rd grade videos, so I'm going to have to be very careful. Okay, rounding whole numbers. Last time we did talk a little bit about rounding, and we used pictures to show like when a point is physically closer to one whole or another, and that's how rounding goes. But we're going to talk about rounding whole numbers, but because this is a new stream, I am, as always, going to go ahead and highly, strongly, and in all other ways recommend these videos on Khan Academy already. I am not affiliated with Khan Academy in any way. They are not paying me, but I do think they are an excellent source of information. You should absolutely watch these videos along with mine to get a more full education and a more full understanding of the topics involved. All right, rounding whole numbers. So what it's going to do is it's going to give us an absurdly large number, 1,627,187, and it's just going to say round it, in this case, to the nearest 10. Yeah, no problem. So we don't really care about most of this number, right? This number is big and long and complicated and it looks scary, but this is a good time to remind your student that not all of the information that's presented is important. Is important. When we're rounding to the nearest 10, all we care about are the last 2 digits. That's it. Everything else is unnecessary. 87 rounded to the nearest 10 is 90. The rest of it's just copy paste. 1, 6, 2, 7, 1. Just change the 87, round it up to 90. I don't remember exactly when and how I learned how to round. We talked about it in third grade, but this is a time when students are going to really start to use it a lot, especially since we are going to be talking about decimals later on in the 4th grade curriculum. So it's definitely important to get this idea of rounding get it down. Round 25,000 to the nearest 10,000. Now 25,000 is right in the middle of 20 and 30,000, right? And we decided, we being, I guess, mathematicians some time ago, completely arbitrarily, that when things are exactly halfway through, we got to make a decision, right? Go up or go down, and we decide we're going to go up. So if we're going to round 25,000 to the nearest 10,000, we're going to go up to 30,000. Again, that decision didn't have to go that way. We could have decided that at the halfway point you round down instead, but we didn't. Round 2,826 to the nearest 100. So again, I am only interested in the last 3 digits. I'm either going to stay down at 2,800 or I'm going to go up to 2,900. Those are my only 2 options when I'm rounding to the nearest 100. And I'm definitely closer to 2,800 than 2,900. I hope you can see that without me having to draw out a chart, like we did last year. I think it depends on whether 0 is at the beginning of the number line or the end, 0 to 9 or 1 to 10. Yes, that is indeed a common theme that's going to come up. For now, we're going to be starting the number line at 0. But you're right, there are many contexts. This is 2800. There are many contexts in which we actually start at 1, and that just ever so slightly throws a lot of the arithmetic off, and it can be very, very confusing. Round to the nearest 1,000. So again, I'm highlighting the thousands and everything after that. We're either going to go up to 2,000, or we're going to go down to 0, or to stay down at 1,000. Well, 639 is closer to 2,000 than it is to 1,000, so we're going to round to the nearest 1,000, which is 242,000. I hope this stuff is making sense the way I'm explaining it. We are rounding to the nearest 10, so again, none of the digits matter except for the last 2. The only 2 options are round up to 20 or stay at 10. With 5, we round up. So 20 is the very last 2 digits, and everything other than that is copy-paste. 939,520. I have a feeling that these problems are intended in part to get students used to working with large numbers without actually asking anything particularly demanding of them, so that later on, when students do have to add and subtract and, God forbid, multiply a number that's this size, they will at least have the experience working with those numbers. Round to the nearest 1,000, that would be 4,000. The only other option is 5,000, and 358 is definitely closer to the bottom than it is to the top, if that makes sense. Round who cares to the nearest 1,000. All right, so we know it's going to start with 394. And again, we can either go down to 2,000 or up to the next one, 3,000, whichever one is closer. Since this is past the halfway point, which is 500, this will round up to 3,000. And by the way, you may be asking whether or not these commas are necessary. That is indeed a question that a lot of students will ask. I wonder if it will accept with the commas in here. Let me find out. Okay, so you can put the commas in as well. Whether you do or not is really a matter of personal opinion. One thing I do want to mention, though, is that in Europe, they use a period, a point, a full stop for those commas instead, and they use a comma for the decimal point, which we normally use a period for. So that is a little bit of not backwards, but opposite sort of thing to expect if you are European and come to America or vice versa.